This video is going to serve as an introduction to statistics. So you'll find the information about mean, median, and mode in your textbook under chapter 15. However, I've decided to kind of disperse that chapter throughout the semester. Statistics is a prerequisite to this class. I know some of you may actually be taking it at the same time or concurrently. However, it's definitely not recommended. Things will come up that will require some statistical background. So if you are taking it currently, just kind of take that on with a grain of salt, and you may have to reach out and find help, whether it's through me or through the Student Success Center, to try to get yourself up to speed on the statistics that are kind of expected that you know. So before you do your levels of measurement or scales of measurement lab, I'm going to just refresh your memory on the different measures of central tendency. So mean, median, mode are measures of central tendency. So it is a statistical measure. Sometimes you'll hear it referred to as an average. Really, the statistical average is the mean. It is a single score that defines the center of the distribution. So the mean, the median, and the mode at any given time could represent the middle or the center of that distribution. It just depends on what that distribution looks like. So the purpose of measures of central tendency is to find a score that's the typical or best represents the entire group. So sometimes the mean is going to be the best representation of that group. Sometimes it might be the median, and sometimes the mode. Now, hopefully you have a little bit of an understanding of what these are from earlier math classes, whether it was from high school or earlier college classes. But I'm going to go on and review them as I would somewhat in a statistics class. All right, so here we have different representations. Here we have a bell-shaped curve where your mean, your median, and mode are all going to be the same, right? And your mean in a bell-shaped curve is your best representation of that data. Here we have a skewed distribution. So when we have a skewed distribution where there's a few numbers kind of pulling off to the side here, the median is going to be your best representation of the center. And here we have a bimodal representation. So when we talk about the mean, which is again the arithmetic average, so when you hear that word average, most people assume the mean, but it doesn't always mean that. When you're reading the average in any type of literature, they could be referring to the median or the mode as well, because that would also be accurate. Mean is a sum of all the scores divided by the number of scores. So again, for a population, this is how you represent the population mean. So this is sigma, sum of all the X scores over the big N, which is the number of individuals in that population. For a sample, which is what we'll talk about mostly, here mean is represented as an M. Sometimes you might have learned in statistics the little X with a hat over it was the mean. But since most publications use the M, and that's what you'll need to know for APA, that's what we'll represent it as. Again, the sum of all the scores, so the sum of X, so X being the scores in the sample, and N being the number of individuals in that sample. So this is little n. So again, just to remind you that, typically we have Greek letters representing population scores, capital N for the number of individuals in a population. We use alphabetic numbers for sample values, and the little n is going to indicate sample numbers. For this example, here we have our X values. Now, just to remind you also that sometimes you have an F or frequency. So for this, you wouldn't just add up 5, 4, 3, 2, and 1, because you have 3 5s, 4 4s, 6 3s, 4 2s, and 3 1s. Okay? So in order to add up all the X's, you have to actually know that you have this is equal to 15, 16, 18, 8, and 3. So we'll do that on this page here. So we have 3 5s, which gives us an f of x of 15. We have 4 4s, so that would be 16. We have 6 3s. We have 4 2s, which would be 8, and we have 3 1s. So now we have to add those all up. That gives us 60. then we have to add up the frequency as well to know the number of individuals. So it's the frequency. We don't have just 1, 2, 3, 4, 5 individuals in our sample. We have 3 plus 4 plus 6 plus 4 plus 3 individuals in our sample. So we have 20 individuals in our sample. So over here, we're going to take 60, which is our sum of x, divide by 20, and that's going to give us 3. So the mean for this data is 3. You can also think of the mean as a balance point. And I'm not going to go into this too much, but most likely you've learned about this in statistics, or you will learn about it. And so the idea is that we have to have the same number of values on one side of the mean as we have on the other. And so it's this balance point. We can also think of it as dividing the total equally. So let's say we had $84 and we had 4 individuals, okay? If we took that amount and divided it equally among those individuals, that's our mean. So we took 84, we divided among 4 individuals, that gives each of them $21. And that's just another way. So if this doesn't make any sense, if it's just you're fine with, okay, I add up the numbers and divide by the total number of individuals in that sample, that's fine. This is just 2 kind of different ways to help you kind of understand really what that arithmetic mean is. So the median is the middle of the data set. So the midpoint of the scores in a distribution where they're listed in order from smallest to largest. So the median basically divides that into 2 groups of equal size. So it takes that sample, those sample numbers, and it divides it into 2 groups of equal size. So it's the middle score. So if your n is an odd number, and I don't know why the 5 here is a different color, you simply put them in order from smallest to largest. Here we are here, 3, 5, 6, 8, and 10. And then you would just simply take that middle score. And to find what that middle number is, we take n plus 1, divide by 2, and that gives us 3. So we take the 1, 2, third score. Here it's real easy, because it's a small data set to look at it, but if you have a larger data set, you might need to use that calculation. Now, if you have an even number, you put them again in order from largest to smallest. And then the median is somewhere in between these 2 scores, right? So we look here, we can simply add those scores up and divide by 2 and get 5.5. So this is kind of for your basic data sets. And I don't think in here we'll come across anything more complicated than that. But just keep in mind that sometimes it gets a little bit more complicated to figure out what the median actually is. Now the mode is the one that has the greatest frequency. And the mode is going to be used mostly with your nominal data. And so it can be used with any scale of measurement really, but it's the most accurate to use with that nominal scale of data. And it corresponds to an actual score in the data. So here, let's say we had positive, negative, and neutral. This would be maybe like how you feel about statistics. I feel positive about it, I feel negative about it, or I feel neutral about it. And so which one has the greatest frequency? Here we can see that negative feeling. And it is possible to have more than one mode. So here you can see you have a bimodal distribution. And so you do have 2 scores that are, this one's obviously more frequent, but it wouldn't be fair to say this is the most frequent score when you have another one that's also much more frequent than others. So you have this bimodal distribution. So when you have symmetrical distributions, your mean and median have the same value. So here's your bell-shaped curve or your normal distribution, and all 3 measures of central tendency have the same value. Here we have a symmetrical distribution, and our mean and median are the same, but your mode is bimodal. And here, there's no mode because the frequency is the same across all, and the mean and median are the same again. So a distribution may have more than one mode or no mode at all. And here's a skewed distribution. So in a skewed distribution, your mean minus the median is going to be greater than 0. So the mean is much more influenced by these extreme scores out here in the tail than the median is. And the median is required to, divide the scores into 2 equal parts. And the mode is going to always be that most common peak. So when you have a skewed distribution, your median is really the most representative of that data set. Here we have a negatively skewed, and so here the mean minus the median is going to be less than 0. And here's just a table that kind of summarizes everything for you. So I'm not going to read through it for you, all of it, but know that it's here. It's also in the lecture notes that have been provided. And it just kind of tells you also like when you would, for what types of scales and how it would be appropriate to use, and then when it will also be misleading to use. And here's, again, just another summary of just kind of saying how to select measures of central tendency. Again, our mean is our default. It's best used with a normal distribution. The median, think of it as in terms of extreme scores or skewed distributions. The ordinal scale as well. The mode, best for nominal scales. And then just some other things that in terms of statistical measures. So hopefully that'll help you refresh your memory about measures of central tendency, and then you can go on and complete the lab with no problem. And here's just leaving you with a little meme. She said I was average. How mean.